Okay, thanks everybody. So our last panel today in the new moves in authentication track is a discussion on biometrics. And so here to moderate this panel is Brett McDowell, Executive Director of FIDO Alliance, and Brett will introduce the panel themselves. Brett.
Thank you, Andrew. If anyone sees Rajiv Dalakia, flag him down, let him know we're in this room. He's our missing panelist. All right, so let's see. What we'd like to cover today is give you a baseline of what's going on with biometrics, generally speaking. So we're going to look at biometrics from a lot of different angles. You should be able to leave here with a pretty good update. What's different about biometric technology now than, let's say, a year or two ago, how it applies in the consumer market, how it applies in the enterprise market, and some of the kind of macro trends around biometrics. So I'm going to start by just teeing this up a little bit. So the history of biometrics would start with what I call big iron biometrics, so border control and law enforcement. You know, governments were the customers, and they were managing different kinds of systems where you have to identify someone out of a crowd. So not really looking for that one-to-one matching, but that one-to-many matching. I got a warm seat for you right there at the end. We're good. And no problem. So that's one of the trends. So it starts there. It starts with the biometric industry of, a decade ago, 2 decades ago. And one thing to keep in mind is the size of the sensor has a lot to do with its ability, with its performance. So when you go to a border that is using biometrics, you're using a more expensive sensor and a larger sensor than the one that you get on your smartphone. And though this has some direct correlation with performance expectations. That's something you'll hear more about from Greg. So that's one thing to keep in mind. So the industry has shifted because now it's available to consumers. Now it's not available to consumers because there are biometric kiosks set up around the place, or when you go to check out, there's not a biometric sensor there. In this country, there are examples of that in India, and you'll hear more about that. But it's in your laptop, it's in your tablet, it's in your smartphone. And it's different modalities. So not all biometrics are created equal. There's fingerprint, you need to understand fingerprint, and have to understand the context of that, comparing that to facial recognition, comparing that to video, comparing that to iris, comparing that to other forms of detection, which you'll hear more about on this panel. So there are different things to know. So not all biometrics are created equal, so you kind of have to understand the modality and what you can learn about that. Performance has really improved, even though these sensors have been shrunken down, they've gotten smarter and better. And you have to understand the threat model. When people talk about biometric spoofing attacks, understand, all right, what is that? What does it take to execute a spoof attack? What's the industry doing to mitigate the risk of spoof attacks? And how does that affect me if I want to deploy biometric authentication for my enterprise or my consumers? So with that, I'm going to start turning it over to the panelists. I want them to introduce themselves, why they know something about this topic, why this topic is important to them and their company, and then give some opening comments from their perspective. So I'm going to start with Rajiv, who's going to kind of take my simple introduction a little bit further and kind of talk about how we got here and what's different, and especially the role that device manufacturers or OEMs have played in shifting the relevance of biometrics from something that was almost blind to the commercial sector to something that is very present and important to everyone in the commercial sector. Rajiv?
Thanks, Brett. I'm Rajiv Dalakia. Sorry for being late. I was just ended up finishing a session, speaking in another room, and I had to trot over. So I am with a company called Knock Knock Labs. were one of the original founders of the FIDO Alliance and primary authors on some of the specification work. Some of our founders have spent more than a decade in the biometric space. The other set of founders of the company came from a deep security background, both in the PKI space. My last company was a company called PGP, Pretty Good Privacy. So we brought an interesting perspective to this problem. In some of our journey was really through one of our founders trying to bring the usage of biometrics into the web and the mass market, which is kind of where the journey started. How many people here are oriented into the distinction between server-side biometrics, client-side biometrics? A couple. Okay, so what you should understand is as Brett said, there are primary two modalities. The idea that when you present a biometric, it needs to be captured. It needs to be stored somewhere, typically not as the image, but as a template, some abstraction of that image. And then later on, when you present yourself, again, it needs to perform some kind of a match. And all of this needs to be done in an accurate way, very fast. And what's happened in the industry over probably the last decade is that an enormous amount of venture capital has gone into making this process fast, reliable, efficient, and low cost. And when I was speaking in the other room, I said, if you really want to watch this space, follow the money. Back in 2012, Apple put a $365 million bet down to buy a fingerprint sensor company called Authentication. And while fingerprint sensors had been present on things like PCs before, and the Motorola Atrix phone actually had an integrated sensor in the back. Apple's integration of that fingerprint sensor, its particular design, performance characteristics, and security elements underneath was a game changer because it really gave a big boost to this idea of doing all of the things that I mentioned on the client side. So in the case of what Apple brought to market and what Atrix did and others, the matching of the biometric happened on the device itself, your personal device in your possession. It was typically sequestered, as in the case of Samsung and Apple, within the depths of either a secure element or a trusted execution environment. And the manufacturers gave us a gift. I've been in the PKI strong authentication space identity space for a while. And we struggle with rolling out mechanisms that we have to train our end users on. We have to make sure that we set up our support departments to deal with the phone calls when end users can't figure this out. And the nice part about biometrics is that as they've started to flow into the marketplace, these OEMs have conditioned our end users to be opening their devices with these gestures. Today, the most common gesture is the fingerprint, but there are many others: face, voice, eye vein, others that are on the horizon. There are active methods where the user's actually doing something to authenticate themselves. There are passive methods where you might be wearing a band that's measuring your cardiac pulse rate. So there's an enormous variety of these mechanisms that are flowing into the marketplace. Those are separate and distinct from the server-side biometric, which has typically been the domain of either proving your identity for the very first time when you present yourself for enrollment, has been the province of nation states. As you come across borders, for example, you'll encounter those kinds of things. So, for us as Knock Knock Labs and for some of the people on this panel, FIDO was a journey to say, well, if you want to replace passwords, we would be fools to ignore these technologies that are flowing so fast into the marketplace. And so the question was, how do we design infrastructure that allows you to take advantage of all of these mechanisms without having to change your backend or your developer API every time that a new mechanism matures in the marketplace? And that's essentially what the FIDO Alliance has been working on. from a standardization perspective. It's not a theory, it's been rolled out to over 1 billion users, and it's in use at a tens and hundreds of millions of users scale today. And it works effectively to accomplish not just security, but also ease of use and a business advantage for users. So I'll pause there.
Thank you. Okay, so thank you, Rajiv. And I'd like to now move, so you've heard kind of where biometrics started, and then it started to flow into consumer devices for device unlock, and there's been some standardization to take advantage of device unlock to become application unlock or application login, remote application login. I'm going to ask Das to introduce himself, what his company does, and talk about maybe a little bit more of that, but also some other applications of biometrics today in the consumer space and citizen-facing space. It's not law enforcement, it's not border control, but it's also using biometrics in yet another way. Das.
Thanks, Brett. My name's Ridhaman Das. I represent a company called iVerify. iVerify has a biometric modality where we look at the blood vessels in the white part of the eye and the microfeatures in and around it. That's what Iron Biometrics, as Rajiv was mentioning. We were acquired by Alibaba and Ant Financial September of last year, so here I am representing both Alibaba and iVerify. So iVerify, even pre-acquisition, has had a lot of deployments and success in financial industry in the US and Europe, as well as in Asia. We've seen a lot of demand in banking applications to want to integrate a separate software-based biometric directly into that application. Right? What that does for banks is, for example, with Touch ID, it doesn't give banks an assurance of who the user is. Right? You can enroll your son or daughter or your wife on the Touch ID, and so they can log into your bank and the bank has no idea which one of the two users or which fingerprint logged in. So we've seen a lot of demand from mobile wallets as well as payment wallets and banks to deploy biometrics directly in their mobile application. We've got several banks that are using iPrint as a FIDO authenticator. The advantage they get there is the credential-based key exchange mechanism as well as a standardized interface. If they can talk to the Google Android fingerprint sensor, they can now talk to any other authenticator. We've also done quite a bit of work in China. The deployment is very interesting. China has a national database, a government database of everyone's face. So when you go to get a Chinese ID, which can double as your driver's license, the face picture that they take is actually stored in a database. That has been made available to a few companies, for example, Tencent and Alibaba and things like that. So what we are able to offer with the national database is a no enrollment use case for software-only biometrics. So meaning that the first couple of times you log in and use your Alipay wallet or your WeChat wallet, it is actually doing a server-side match against that face image and using only face as a modality, and then gradually, as you start using it, in the case of Alipay, that it starts to build up your iPrint template so it can switch to a local authenticator, right? And then you can then use local biometrics only. There's also interesting forces going around in interesting market forces in Turkey, where you might have seen Turkey outlawed Touch ID, right, for the uses of banking. So we suddenly saw a huge spike of deployments in Turkey from banking. Some of the largest banks in Turkey are starting to adopt face and eye and other software-based modalities. And obviously when it comes to national databases or government-mandated biometrics, there's always a very thin line that you have to walk that balances privacy and convenience. Right? In China, the cultural forces at play seem to prefer server-side biometrics. They're okay with that. We haven't seen any big concerns come out from the consumers. In India, it is the exact opposite. You may have heard of Aadhaar. Aadhaar is a national database of 10 fingerprints and iris and face that the Indian government rolled out. It was initially positioned as an optional service that you may use if you were illiterate or didn't have access to banking and financial services and things like that. Gradually, it has been made more and more mandatory, and that has been challenged in the courts, right? And people are really uncomfortable that now Aadhaar is required for income tax purposes. We've seen a similar situation in Indonesia. Indonesia has the EKTP system, which is a national database as well. Indonesian law states that you cannot move biometrics outside of the borders of Indonesia, but it was found that EKTP was deployed on AWS, and AWS didn't have a data center in Indonesia, so the national government database was actually not housed within the borders of Indonesia. Made a lot of people uncomfortable, as well as reduced the trust that people had in those systems, right? And broader overall in the biometrics industry, what we continue to observe is biometrics is actually two things. The first part is the matcher, right? Does this biometric that has been presented to me match what I saw in the past, right? The enrollment image, or the enrollment template, more accurately. The second part of it, which is equally important, if not more important than the matcher, is the Liveness Engine, right? I need to be able to tell if I'm looking at a live person versus a spoof image, whether that is a presentation attack like an eye hole cutout in our case, or 4K video, 4K stills, and things like that. And good biometric authenticators are able to deflect not just matching attacks, but also liveness attacks. And there's a few things going on with multimodal biometrics, which is where several different biometric modalities, in our case, face and eye, are being used together, and that strengthens the robustness of the biometric and provides an additional liveness check.
Thank you, Das. So far we've heard about kind of where biometrics originated, big sensors, big companies, big systems, were basically just rolled out by governments, to sensors that were showing up in device for device unlock, industry standards efforts to use that device unlock sensor to be able to log into applications on device over the web, and also now the software authenticator side of the story in the consumer and enterprise market, where you're not dependent on whether there's a sensor built by the OEM. You can actually add a biometric algorithm solution in your app. So wherever your app goes, you also can do biometric authentication. And in doing that deployment scheme, you still have a choice about what to do in terms of matching. You can match on device and use those industry standard protocols for online authentication, or you can match on server. So that's a deployment option. Now I want to turn to Greg, have him introduce himself, his long background with biometrics and his company's expertise in biometrics. And basically, I'm going to ask Greg the hard problem of, can you fill in the biometric literacy of the room, some of these things, these concepts that were already introduced, presentation attack detection, spoof detection, and kind of catch us up on what is the state of the art, and how should the people in the audience evaluate biometrics when they're looking at integrating them into their current solutions.
Okay, Brett, I'll try. Good morning. I'm Greg Cannon. I'm the Chief Technology Officer of CrossMatch Technologies, and it's a leading biometric identity management and secure authentication provider. Since 1996, we've developed those big Iron Biometric systems that Brett just mentioned, and relevant for this conference, we participate in the cloud identity market with our own enterprise composite authentication solution known as Digital Persona, and it's designed for computer network application and VPN access. To fill in the gaps of the biometrics, biometrics, I think pretty much when everyone raised their hand, I think everyone has a pretty good understanding of what they are. They're physiological or behavioral distinguishing traits that really reflect something unique about you, about your identity. And they're very valuable from certainly a secure authentication perspective because they're very convenient. You never lose your biometric, you don't leave it at home, you don't forget what your face looks like. And so oftentimes you use your biometric in a way that just is more convenient than using a password, and arguably just as secure as most of the low entropy passwords that exist. And they're a strong proof of presence. It's a lot better to actually put your own finger on something and try to prove your identity in a transaction than relying on just perhaps a button or a device, right, that you might have and pretend that represents who you are. There's been a lot of progress in the biometric industry over the last, probably forever. Certainly a lot of acceleration in the last couple of years with the machine learning and the accuracy, especially in face. The facial recognition accuracy has really improved rapidly over the last couple of years. Roughly, matching a biometric system works basically the following way. You enroll something, you get a template. You then later on put your biometric on a sensor, and you get another template. You match those two templates, and you get a score. You compare that score against a threshold, and in modern systems, we're taking that score. If it passes that threshold, we're going to unlock a cryptographic protocol. If you set the threshold too low, anyone can get in, right? Very convenient for the user. You never fail to access your own device, but if anyone picks up your device, they get in. That's a placebo biometric, largely. If you set it too high, you never get in. It's for the Department of Energy and Atomic Labs. You really, really have to work hard to gain access. A useful threshold is in the middle, and that's where the biometric industry has really spent most of their time. To give you an idea of where we are at right now, we operate at an operating point, i.e. you set a threshold at 47 on a scale of 1 to 100. If that threshold is exceeded, that happens only 1 in 100,000 times for a false accept. Meaning, if you were to try to pretend like you're me, that only happens 1 in 100,000 times. Or trying to find someone that matches me, you need to get 100,000 people lined up to match me. And of course, on a phone or on a computer, there's rate control and things like that to mitigate that threat even further. The false rejection rate at that operating point is roughly around 3 or 4%, which means that 1 in 25 times you miss, and you got to do it again. That's a pretty good use case. It makes for a very successful adoption of biometrics and why you're all using them for unlocking your phones and for, as Brett said, beginning to unlock financial transactions and do interesting things in your lives. As we mentioned earlier, we have a threat of presentation attack detection, liveness, or materials used to try to impersonate you when used. And I think the industry is taking this very seriously. Every biometric vendor knows that in order to really achieve the promise of biometric technology, they need to address that threat. And we're doing so in a kind of a systematic philosophy. I call it a risk spectrum. We're attacking those easy to achieve attacks, something like a really very inexpensive molding material and glue, or video for a face, or something for an iris, and looking for interesting interactions between the illumination systems of the biometric system, or the sensing systems, or the electronics, or your physiological response to achieve a liveness detection system that both doesn't impact the actual user's convenience, so it doesn't falsely detect you as an artifact, and does defeat most of the low-cost attacks. I'm going to break here because I think we need to spend more time for the last person. So if you have any other questions, please be...
Sure. Thanks, Greg. So I think Greg going to do something. I'll give you the gift of another acronym, Presentation Attack Detection, or PAD. So you've probably heard of FRR, and so false reject rate, FAR, false accept rate. One of the things about biometrics is they are probabilistic. They're not deterministic. It's not an automatic one-to-one like a password or a PIN number. There's a probabilistic range, and that range of how tight or loose the sensor is set at is configurable. So that's something else to kind of be aware of with looking at biometrics, and start looking at biometric solutions that have some kind of pad detection. That's what you're looking at, presentation attack detection, some kind of pad solution. So thank you for that, Greg. And
hey,
now,
Brett, just a five-second comment. Just to make sure everybody understands, all authentication mechanisms are subject to some kind of probability. When you have that smart card and you give your user a PIN, you haven't really quantified what the possibility is that they've shared that with someone else. It just so happens the biometric industry actually has a fairly interesting process to go quantify some of this stuff. So don't be scared by the fact that it's probabilistic rather than deterministic. All authentication mechanisms are subject to this kind of issue.
yeah, I hope I didn't scare anybody with that statement. But just good for you to keep that in your kind of stack of things to look at. And if you are ever put in a position of being able to turn those knobs and calibrating a biometric, to know what your outcomes are. So I want to go to Kevin now, because we are officially 2 minutes from being out of time. We're going to go over. The only thing on the other side of this is the long lunch break and expo. So we're going to try to eat into those few minutes since the keynote got the whole morning off late. So please bear with us, and I want to let Kevin introduce himself and talk about, bring this home and really focus on consumer experience. His company has a lot of experience with consumer sensors and is a supplier to some of the most popular devices in the world. And so he's going to kind of bring this home and talk about how consumers are using this technology and how to think about that side of the equation. Kevin.
Thanks, Brett, and good morning, everyone. I'm Kevin Lynch from Synaptics. We make touch devices, so the touchpads that are in laptops, the touch controllers that are in the smartphones, as well as the biometric fingerprint sensors that we're seeing in some of the devices. From my perspective and from Synaptics' perspective, a lot of what has changed and the progress that we've made has been we're seeing differences and changes in this login ceremony that we're asking consumers to engage with. Biometric presentation, social login are the things we're going to be seeing over the course of the next year, really providing the consumer a much more relaxed, convenient way to enter systems. We've mentioned before about the fact that biometrics have been traditionally used in law enforcement, and I have to give credit to the folks at Apple for normalizing the use of fingerprints and taking it outside of a worrisome environment. The transition that consumers are going through is pretty clear. Ron Miller from TechCrunch mentioned in the keynote this morning that being able to use his fingerprint instead of typing a long, complicated password changed his life. Now, in this room, we kind of walk the walk with regard to security and identity. Consumers are starting to realize the value of that, the role that they have to play in what they're being asked to do. Friction is being taken out of this process at an unbelievably rapid pace. When I look at what the key initiatives are, it's to make it a fully frictionless activity and experience from the consumers. The touch-based information that we're able to collect from our touch controllers on the smartphone delivers a tremendous amount of information about the personality and personal to the consumer. We're able to see things like hover time, angles that fingers are moving at. It's very straightforward to take that information and map it to the characteristics of an individual. And these things happen continuously in the background. So if we can solve the problem, and another key initiative is privacy, if we can solve that privacy problem, we've got a rich set of data that exists, that's very personalized to the user, that can be used as an authentication signal. I'd like to see the progress that we're making from authentication on demand to recognition as the default. We want to expect our devices and the environments that we operate in to recognize us. We're beginning to see these speech AI assistants that are out there. They'll be responsive to voice, but they'll be responsive to any voice. I want them to recognize me. I want them to recognize my family individually and be able to make that part of the experience that I'm going to be engaging with the technology as we move forward.
Thank you, Kevin. So I'm going to have some parting thoughts. If anyone does want to stick around and ask questions, you're welcome to do that. We'll stay here for a few minutes to take questions. But to wrap this up, I think we've reported a lot to you, kind of put biometrics in context, and we've talked about a lot of the drivers for why biometrics are showing up everywhere and why anyone who manages an identity system has to understand the role biometrics can play in their system, know how to evaluate it, and where and when to put it on your roadmap. One of the things I want to summarize is, even though we talked about the presentation attacks and what to do about that, and how to trust these assertions of the effectiveness of a biometric, I'm happy to make something of an announcement, if you didn't already know, that FIDO Alliance is rolling out a biometric certification program that's going to help you put more trust into these devices, because it's going to be validated by third-party labs to what is the bar that our community has set as commercially viable. We are not going to be publishing FIDO validated false accept rates for biometric sensors. Instead, we're going to publish our standard for what we think is commercially viable biometric performance, and these are the biometric solutions that pass that bar. They may be quite better than that bar, but they're certainly not worse than that bar, validated by third-party labs. So that should be rolled out end of this year, early next year, and that should really help you as well. The other thing is biometrics are being driven to improve usability, right? That's quite obvious. It's just so much easier to use them when they're done well than all of the other user challenges we've had before. But also, if you've been in the authentication track, more this morning, you'll realize that regulatory bodies, when you match that biometric to a cryptographic key store that's well protected, you're also increasing security. So now you're increasing convenience, and if matched to a cryptographic key store and protocol like what FIDO gives you, you're also increasing security of the solution. So this is a real gift of time where you don't have to make that trade-off anymore. So biometrics are a key to being able to improve the security of your authentication systems while improving the usability of those authentication systems at the same time. And then depending on your privacy tolerance, there's also the option of leaving all of this matching on the device side versus needing to build a database. And yet, there may be also industry efforts and, of course, some government efforts, as reported, where there is a biometric database that can serve for kind of KYC purposes in tandem with FIDO for credentialing and authentication. So if you're interested in finding out more about this, come talk to us. You can be a part of this in FIDO Alliance. But right now, I can let those go who need to run. Otherwise, we'll take questions. Yes, back there. Yeah, I think I can hear you, but Mike's going to come your way. Right in the back on the left side.
Check.
Yep.
Hi, thanks for the introduction. I'm in an organization which is on the cusp of evaluating several factors, and we know that no single factor is universally acceptable, and preferences are going to be across the factors. So from your experience, could you suggest a factors framework that I can use as a prioritization model or efficacy measurement model as I evaluate multiple factors as part of my biometric solution?
Sure. I think Greg was going to take a shot at answering
I'll
that.
take a look at it. First, I'd ask you to look at this NIST Strength of Function Authentication Framework, which is being developed right now. It's called SOFA. There's a SOFA B, and it attempts to establish both in terms of presentation attack detection and in accuracy and error and in convenience and usability, sort of the relative value of a particular authenticator, whether it's a biometric, not necessarily going into particular modalities, but biometrics versus passwords versus device versus other context information, and being able to use those, as you say, multiple or composite factors to make a more informed identification choice. So I'd push you to SOFA if you could look at that.
Thank you. Any other questions? Okay, we got another answer.
The other bit that you should wrap into your analysis is that the right authenticator for any given situation is a factor of three things. What usability does your use case mandate? What's the risk profile or security that you need? And what are the economics that you're willing to bring to bear to solve those first two problems? If you try to solve for the first two without solving for the third, you'll end up in a wild goose chase for a while. And so it's important that you evaluate those three things together. If you're using it in the context of a consumer use case, one of the things that you should look at very strongly is what I call consistency of failure. And what I mean by that is that all authentication mechanisms fail in some way. Users forget passwords, they demagnetize cards. There's all kinds of things that happen. So what's important in a consumer use case is that if the failure is consistent, users typically self-train on how to get around them. So for example, on contemporary fingerprint sensors, if you have oil, you have water, users get used to the idea of wiping. For some other modalities, there are too many variables where the user is not getting enough feedback about why the authentication is failing. Is it because of lighting? Is it because of angle? Is it because of orientation? And so we're still evolving for some of these other mechanisms. Fingerprint sensors have been around for a while. They're unreasonably effective because they've had 10 years and over $1 billion of venture capital that went into making some of those things effective. The other modalities are slowly gaining ground, and they're coming up a curve very, very fast. But consistency of failure for consumer use case is something important to look at.
Well, we're two for two because Pavan and I work together at eBay. He's on my team, and I'm going to add to his question. I've been working on biometrics and MFA for many years. Now at eBay, obviously the mentality is back to your point on the consumer side. You really got to think about giving the user what they're really looking for, which is to get to the site, get to the app, and get things done. And all of these things can get in the way, right, of that. And for us, we all know we want to be cool, make them look like 007, use all sorts of factors, but in the end, it's about getting out of the way into the business. And one of the issues I face, and leading to the question, is when it comes to some of these biometrics that are not done locally, which I like because you enroll once, you can use across all your devices. So you reduce friction quite a bit, like a facial recognition that you enroll once and you can use on all your devices. I like that. But that said, I also understand the risks associated with such an approach. So I wanted to ask the panel the question, why wouldn't we collectively start looking at how to bring these cloud-based or database-based biometrics and always figure out a way to have a range or an accept range of, if you combine that with another factor that's passive, such as a device ID or something that's trusted, in addition to the biometrics that's cloud-based. What does the panel think about such an approach so we can really unleash all sorts of biometric approaches, local or cloud, but we always mitigate massive attacks. If somebody gets to the database, doesn't really matter because the templates are unusable on the hacker's device. So maybe I'm going too far, but I want to get some of your thoughts.
Yeah, I think a diversity of modalities is going to be important, and it has the benefit of being able to avoid some of the pitfalls as they get discovered, or a breach as it gets discovered. It also allows you to accommodate the easiest, lowest friction path for the consumer and for the reason that they're authenticating themselves. The level of tolerance, we had a threshold, and the payments industry has set that threshold. You have to be authenticated to this point, and then you're okay to go ahead and do a transaction. That level is not the only level. There are lower levels, there are higher levels for step-up authentication. So we should look at systems that allow us to combine information that's available in a database, for example, to combine information that's generated on the fly, as well as balance both of those things with the consumer experience and the user experience.
Yeah, if I may, I wanted to try to summarize to get to the heart of the question. So with pure remote match biometrics, you get a convenience benefit that you don't have to re-enroll a new credential on a new device. With FIDO biometrics, I'd say, but before I leave that, but you have the risk of you've got this database of credentials and their biometric templates. With FIDO biometrics, you don't have any secrets on the server, no biometric templates on the server, but you do have to re-enroll every device because it's ultimately the credential that stays on the device that you're using to log into your application. So the question is there a hybrid? Can a service provider successfully reduce their risk of replay attacks of stolen templates? Let's say there is a data breach of stolen templates. Can the service provider protect themselves from that risk if they're also, every time they take a remote match biometric template, they're also using some kind of device ID to go with it to mitigate the risk? I think it's a big question that requires a lot of committee discussion, but we'll do what we can. Das, next.
Sure. We have deployed a system similar to what you described, right? Where there's a server-side mesh that removes the need for re-enrollment and portability, right? What we've found is, well, what we've done is that the Liveness Engine is really all client-side, right? So the server does very little liveness because ultimately it's a template that's coming into the server. But much like any of the other client-side biometrics, the decision of whether we're looking at a spoof subject versus a live subject is done on the device, right? Because as you're capturing the images, you're able to really look at all the sensors and determine that information. It's never just one sensor that can make that determination. To give you an example, we saw an attack where there was a replay attack where there was a stream of images being fed into the camera pipeline, right? So we thought we were seeing real images, but it was the hardware and integrity of the camera pipeline was violated, and it was being fed in.
Thank you. Greg and then Rajiv.
All right, so I was going to say, it really depends on your security, privacy, and convenience balance, right? And one of the strengths of FIDO is that they wrap this whole concept into this encapsulated authenticator. And so, you know, there's nothing really wrong with any particular solution, really. It's just a trade-off. I would say there's some technologies that are very interesting associated with this. First is this idea of template protection. So templates are reversible. Templates do leak biometric information. Currently, if you have a fingerprint template, whether it's minutia or pattern, it can be reversed. It can be either reversed from a direct reversal into biometric information, or it can be reversed kind of like a dictionary attack. And that's true for every biometric. It can be used in a hill climbing attack. It can be used to leak biometric data at scale. So when you put biometrics in a database, you have to be very careful, and I think you should consider it as part of the authenticator. But with template protection, you can transform that biometric template into something like a hash function. And with some modern privacy technology, some of these Bloom filters, one with a many-to-many kind of a collision rate, which makes it very difficult to actually reverse, theoretically impossible to leak biometric information. The accuracy is not as good as when you do this as when you use a regular traditional template, but you can also take that template and provision biometric devices securely without worrying about the channel or man-in-the-middle attacks, because that biometric information is non-linkable, i.e. if you enroll a biometric in your biometric system and someone else has another biometric in another biometric system, an attacker who breaches that can determine that identities are in both systems, which is a privacy leakage and of major concern in Europe and America. So we need to invest and continue to push progress in those technologies to allow you to do provisioning for enterprise or for multi-device enrollment in a secure way, as well as being able to reduce the threat profile of all those biometrics stored in the database. But yeah.
Thank you. And Rajiv. And then we will let you go to lunch.
So you know, I think some of our smarter customers went through this consideration. I'll give you the benefit of their calculus. So there's certainly technical measures, and Greg spoke to some of the angles there. But I think in the end, it comes down to the cultural issues in the areas that you operate, and the value of your brand. And if I had to boil it down, I would say for a consumer-oriented brand to be using server-side biometrics, you know, draft a press release that says, we lost your templates. We're sorry. You know, they're really well protected. We had a great cryptographer. We have these terrific techniques that we've used in this context. Don't worry about anything. If you're comfortable with that, if your counsel's comfortable with that, if your senior management's comfortable with that, go press the button, right? I think that sometimes we push this issue of convenience to a point where we don't necessarily calculate all the consequences forward. For all of our customers that have gone through that consideration, they've decided, given their brand and their operating areas and the cultural biases in Europe and in the US, they've decided not to do that. Now, there are interesting places where people are looking at the use of what I'd call ID match kinds of technologies, right? It's a different slightly different use case where you're trying to present an ID of some kind and then scan perhaps a face or something like that. So there are some cases where there's perhaps less sensitivity. I know voice biometrics, for example, are widely in use and not considered to be as sensitive, though you've seen attacks mounted fairly recently through some of the Adobe tools that would be chastening. So I think that whole sector of server-side for consumer-oriented brands, I think, is still a work in progress, and I would advocate caution.
Great. Well, for those of you who are still here, would you please help me thank the panelists.